I have a question for you. Look at these three doors. Behind one of these three doors there is a luxury brand new car, and behind the other two doors there are goats. So choose one of the doors and let us see if you can win a car or not. Hello geniuses, what I have just asked you is a really famous game slash problem known as the Monty Hall problem, or also known as the game show host problem. Okay, so let us continue it and make it more interesting. See, now you have chosen one of these three doors. Let us say you chose this one. Now till here it is really simple. Your winning probability is 1 by 3. It is so simple, right? Now the game show host, or what I am gonna do is this. I will open one of the other two doors which you have not chosen, and behind that door, let us say this one, there is a goat. So now the car is either in this door which you just chose, or in this door. Now the game show host will ask you one of the most difficult choices of your life, that is, do you want to stay with your door or would you like to switch? So the game was not that you have to choose one of these three doors and win a car or not. It was this, that would you switch or not. Now most of the people, based on their feeling and the attachment to their initial choice, will never switch. Okay, but if you see this problem mathematically using probabilities, you have to switch. So why it happens? Number file explains it really well, so I have taken their explanation. See, initially you had a 1 by 3 probability of winning a car and 2 by 3 probability of not winning a car. But I have changed the game when I opened one of the doors that you didn't choose and there was a goat in it. Then the probability of you winning the car if you switch will be 2 by 3, because the probability here got concentrated to this door. This doesn't look intuitive in here, so let us say we had 100 doors like this. So your probability of winning is what? 1 by 100, and your probability of not winning is 99 by 100. Okay, now what I do, I open all the 98 doors. Okay, so now that all 99 by 100 probability got concentrated on one of the other doors. So now here it looks really intuitive that if you switch, you will win the car. Okay, so this is known as the concentration of probability. There is another way to look at this by taking an example. Suppose the car is behind this door. Okay, so we will see by choosing different doors what happens. See, you choose this door first. Okay, and then the game show host asks you to switch. You switched and lost. Okay, so one lost. Now suppose you choose this one. Okay, then the game show host asks you to switch. You switched, you won. And then again you choose this one. The game show host asks you to switch. You switched and you won. So it is 2 wins and 1 lose. And if you don't switch, then it is 1 win and 2 losses. Okay, so the probability of you winning got doubled. So now does this guarantee you a win? No. But if you play this game again and again, you will win double the amount of cars than a person who doesn't choose to switch. So now what do we learn from this? See, the greatest game of probability that you are right now playing is your life. Okay, and it was shown beautifully in this movie named 21 that if you continue to make choices based on your feeling and what your gut says, then most of the time you will make wrong decisions. So always try to think critically based on facts and data, which is your experience, and trying to make decisions based on valid and logical reasons. You might lose in short term, but if you continue to play this game of life like this, then you will eventually win with a greater success rate than others. So I hope you have understood the lesson. Thanks for watching this video, and always remember that math is everything.